Application with ratios and proportions. Okay, so here we go. This is where you're truly going to start doing some math. Okay, so when we were talking in the previous video, it was just building these ratios. And now what we're going to start doing is actually working with them to solve math problems. Okay, now let me introduce you to a question that you probably are familiar with. Okay, so let's do this example right here. Do you see this example? This example is a very common type of proportion problem. So proportion just means that we're going to take a ratio and we're going to solve using different quantities. Okay. And this is a great way to introduce it because it's something you probably have already done or you know this. So here we go. It says Lisa gets 120 miles on 4 gallons of gas. How far would she get with 7 gallons of gas? So this is something I bet if we start talking about miles per gallon and we start talking about how far can you get on your vehicle per gallon of gas, this is something I know you've done. I know every adult who has driven a car wants to know how far they're getting on gas, especially once it gets a little bit more expensive. They want to have an idea of, their spending habits and how their car is working, because right as your car gets if your car is mechanically having some problems, a lot of times your mileage will start to decrease. So anyway, let's talk about this. Here we go. So if she gets 120 miles on 4 gallons of gas, okay, you need to figure out, well, based on that rate, and we're going to go ahead and start using that rate. We're going to use that word rate. Based on that rate, how far is she going to get with 7 gallons? So there's a couple of ways to think about this. Okay. I want to give you a couple of ideas. Okay. So the math that's already set up is this. I'm going to go ahead and describe this to you. Do you notice that they're taking the miles, right? The 120 miles. And what they're doing here is they're dividing it by the 4 gallons. Now, when you do division like this, okay, when we're saying these miles divided by these gallons, there's actually kind of a little bit of magic that's happening, okay? And let me show you the little bit of magic that's happening. When I take the total miles and I divide it by the 4 gallons, what ends up happening is the kind of answer that I get. I want to put your eyes here. This. Okay, so what this is a title or designation for what happens with the number that comes out, right? 120 divided by 4. 120 divided by 4 comes up with the number 30. The 30 is not special. What is special is what you call the 30. And what you call the 30 has a lot of power. Miles per gallon. This is pretty powerful. The language itself, let me tell you, let me read it again for you. Miles, plural, right? Plural per gallon. And gallon is single, right? Gallon, Gallon, right? Two L's. There you go. Whatever. This isn't language class, right? So anyway, miles per gallon. Okay, so that is a singular, or sorry, plural miles, 30 plural miles per single gallon, right? So that's telling me for every gallon of gas, 1 gallon of gas, I will get 30 miles. That's pretty powerful. That's pretty powerful information because now what we've kind of done is that rate, what we've kind of described as something called a unit rate. A unit rate. So this means for every one single gallon of gas, I will go a certain number of miles. This is very powerful information because if you know that you will go 30 miles for every single gallon of gas, then what happens if you put in 7 gallons? Right? So now the thing is that, okay, well, if it's 30 miles for every gallon, then if it's 7 gallons, then that's 7 times 30, right? Exactly. 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 So 7 times 30, right? 7 times 30 miles per gallon means I'm going to go a total of 210 miles. Now that makes sense, right? Here, let me tell you another thing that I'll end up telling students this is that I'll say, hey, does that number sound reasonable to you? Well, think about it this way. Remember that you went 120 miles on 4 gallons of gas? Here's one of the ways I start talking to students about ratios. I think gallons actually has 1L, and I'm going to look right now because I don't want to continue to spell it wrong. Oh, no, it is 2L's. Okay, perfect. Okay, here we go. So here's the thing. What happens if I doubled the number of gallons? So instead of like dealing with 4 gallons, what if you double it and you go to 8? So I take my gallons and I multiply it by 2. What happens if you do that? Well, you'd say, well, that's 8 gallons of gas, right? Yes, it is. So, but, and if this is the thing, is that if this is true, that I went 120 miles on 4 gallons, by doubling my gallons to 8, I also would double the miles, right? Doesn't that make sense? That if you double the number of gallons that you used, that you'd also double the number of miles that you'd go. So that number would be 120 times 2, which is 240. Now, take a look at it. So doesn't it make sense that if you're going 120 miles on 4 gallons of gas, that if you double the gas, you should double the miles? Yes. Hopefully you're like, yeah, logically that makes complete sense. If I went 120 miles on 4 gallons, by doubling the number of gallons, I should double the number of miles. And exactly, because that's how rates work. That's how ratios work. That's a proportion. That's how they work, right? So here's the thing. So if I doubled my gallons, I should be at 240 miles, right? Now, I didn't. I only went to 7 gallons. I didn't put in 8 gallons. I only went to 7 gallons. So my answer, right? Because it's less, it's not double, right? It's not 4 going to 8, which got me to 240. It's 4 going to 7. So my number or my quantity of miles should not be above 240, right? It shouldn't because I didn't double. I didn't go from 4 to 8. I only went to 4 to 7. So my miles should not go from 120 to 240. It should actually be a little less, right? And hopefully you can start seeing this stuff and start to say, yeah, you know what? That makes a little bit of sense. So let's review and talk about a couple of important things that we discussed in just that example again one more time. Okay. And I'm going to tell you what the most important thing is. The most important thing is the division, not just the division, but the name. Do you remember the name, the words that I said, OMG, this is so magic right here that you have to kind of take notice of this. When you set up your division as miles divided by gallons, the answer that comes out is actually miles per each gallon. This is something you need to remember because it creates something called a unit rate, which means for every single gallon, I can go a certain number of miles. So when you start doing your math, I try to tell my students, look, don't just say 120 divided by 4 is 30, because that means nothing. Say it differently. Say it. This is 120 miles divided by 4 gallons gives me 30 miles per each gallon. Start talking like that. Start using that kind of language, because when you say that, your brain hears it and it says, wait a minute, that's a single gallon. So if that's a single gallon, then it only makes sense that I should just take that single gallon and multiply it times 7. Exactly. Because that's how many gallons you're going to put in that car. Okay. Now let's go to number 1. Now, when I go, oh, but let's skip number 1. Okay. Let's skip this one because this one really throws people off. Let's go to question number, I don't really like any of these questions up here, actually, but let's go to question number 3, which is similar to number, let's just do number 1. Okay, here we go. Let's do number 1. It's kind of a difficult one to start off with, but you need to see kind of the variety of type of questions that you're going to get asked on the GED test. Okay. All right. So look at number 1, and we're going to do this together. Billy plays baseball and he has a hit to strikeout ratio. Okay, so the ratio I'm about to see, the numbers I'm about to see is going to be hit to strikeout. And that hit to strikeout is 4-3, or sorry, 3-2. I'm going to go ahead and write that down over here. 3-2. Again, I'm going to remind myself that the first number is hits. The second number is strikeouts. Okay. Now, look at what the next piece of information they give you. Notice that's a period, right? That's a period. And they're going to start a new sentence. Look at the new sentence. It has a lot of information. There's some good information coming up. If he has had 50 strikeouts this season, how many hits did he have? So here's the thing. They're just giving you start off a ratio. They're saying, hey, let's just say in the past, last year, Billy had a hit to strikeout ratio of 3-2, which means for he's getting 3 hits for every 2 strikeouts. Another way to understand this is this. Okay. Hits, strikeouts. Let me ask you a thing. In order to get hit or a strikeout, you need to go to the batter's box, right? You need to go to the batter's box and you need to figure out, is he going to hit this ball or is he going to strike out? Now, here's the thing. That going up to bat is this. This is what usually throws people off. I would say he went up to bat 5 times. So every time Billy goes up to bat, every 5 times he does this, 3 times he will hit the ball. 2 times he will strike out. I like to explain it this way because then students start to say, wait a minute. Okay, so the 3 and the 2, in order, you got the number 5 there, and I think I see where you got the 5. You took the 3 and you added it to the 2, and that's how you got a 5. Now, remember, I can't just do this math and just say, oh, you add this to this. No, 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 no. I'm doing it for a reason, because what I'm doing is I'm saying, hey, do you remember that this is 3-2, which means this is part to part. So 3 part plus 2 part means 5 total. Or another way to say this is for every 5 times Billy goes up to bat, 3 of the times he will hit the ball. I'm sorry, did I write this down wrong? 3 of the times he will hit the ball. I did write it down wrong here. And 2 of the times he will strike out. So this is the situation. And if students start to understand this, then they'll say, wait a minute. So for every 5 times he goes up, 3 times is going to be a hit, 2 times is going to be a strikeout. I'm going to say exactly. So here's the thing. If that's going up to bat 5 times, what happens when he goes to bat 10 times? He goes up to the batter's box, and this is 10 times, not 5 times. He goes 10 times. You'd say, well, do I still use the same ratios or the same? Yeah, I would say yes. Yes, you do. You still use that same information, which said, okay, for 5 times he goes up to bat, 3 times he's going to get a hit, 2 times he's going to get a strikeout. Well, what happens when he goes up 10 times? So you'd say, well, that's really just doubling, right? Aren't you just taking 5 and multiplying it times 2, and I'd say exactly, exactly. You're taking 5 and you're just saying let's double it to get to 10. So if I take it and I multiply it times 2 to get to 10, though doesn't it make sense that, okay, this time it's 10 times. So you still use the same information. 3 times he got a hit, 2 times he got a strikeout. So it's the students will say, so is it still 3 to 2? I'm gonna be like, no, 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 no. Because 3 to 2 is 5. You want to get to 10. You're like, oh, so wait a minute. So that means 6 hits? I'd say exactly. 6 hits. How many strikeouts of the 10? 4? I'd say exactly, exactly. Because here's the thing, all we're doing is taking that information, that rate of 3 to 2, and we're just doubling it. We're just doubling it. We're saying, okay, so if we double 3 to 2, then we're looking at 6 to 4. Exactly. Exactly. And then how many times would he have gone up to bat in order to get a 6 to 4? You'd say, well, 6 and 4, that's 10. Exactly. Exactly. So here's another thing. I say, well, what happens if he goes to 15 times to bat? You'd say, well, that's just the same thing times 3. It's exactly. So if it's 3 to 2, and then for 10 times, it would be 6 to 4. Then I'd say, okay, here we go. Take a step further. What about 15? They'd say, should the hits be 9? Yes. Should strikeouts be 6? Say yes. So this is another concept talking about ratios. And when I start talking like this, sometimes people will say, Darren, that is really confusing me. Darren, I am completely confused. So what I'll say is this. Okay. Let me show you a different way to understand what's happening here. Because again, is it still going to help you answer this question? The answer is yes. You can actually use both understandings about what I'm talking about here. Okay. So let's go ahead and I'm going to show you another way. Okay. Here's another way to think about this. Billy has a hit to strikeout ratio of 3 to 2. So I'm going to go ahead and do that, 3 to 2. And I'm going to write it this way. Okay. Now I put it in this form because hopefully it'll make sense to you what I end up doing this. So again, the 3 is the hits. The strikeouts are the bottom number. Now here's the thing. They're telling you that his strikeouts total is 50, right? So here's the thing. I'm making 2, if you want to call these equivalent fractions, you can, maybe that would make a nice way to understand that. And I'd say, hey, take a look. You'd say, Darren, hey, okay, I kind of get why you're using the division bar. You're using that instead of showing the colon. I'm saying, yes, I am. And I'm doing it for a particular demonstration because I think the math will make sense if you saw it like this. And I'd say, look, you have a fraction of 3 to 2. Okay. My denominator is 2. I'm telling you, I want to make another fraction where my denominator is going to be 50. Now, my denominator is 50. You'd say, well, why did you put 50 below there? I'm saying, because that's strikeouts, right? Because this is strikeouts here in the denominator section. This is strikeouts over here too. Okay. So I'd say this. If I tell you these have to be equivalent fractions, and I'd say, look, what do I have to multiply 2 times to become 50? You'd say, well, you had to multiply it times 25. I'd say, exactly. You have to take 2 and multiply it times 25 to get to 50. So that's what you do to get 2 to 25 or 2 to 50. I had to multiply by 25. So I'd say this, in order to make an equivalent fraction, what do you have to do to the numerator? You'd say, well, you'd have to take the 3 and also multiply it by 25. And I'd say, exactly. It's exactly what you have to do. So I'd say, doesn't that make it 75? Exactly. So that would make it hits. So maybe when you look at it like this, you can say, well, that makes a little more sense. Now, one thing I'm going to show you in the next video is something called a proportion equation. And the proportion equation is very powerful. It's a very powerful tool to help with these specific math problems right here, like this one, and like number 3. So let's go ahead and go to number 3, and let's take a look at it again. And I just kind of we're going to talk about it, and I just want to throw it out there and let you see what you can do with it. Okay. So number 3, go ahead and read this and then pause the video and see what you can come up with. Then I'll go ahead and then play the video and we'll see if we come up with something together. All right, here we go. So if if the ratio of wins to losses, so again, I'm looking at it, I'm going to be seeing a ratio, and it's going to be wins first to losses second for a basketball team is 3-5. Okay, so here we go. Okay, so there's my wins, there's my ratio. I'm going to go ahead and write it down, put it down there for myself, 3-5. And also, here's another awesome habit. I labeled it. So I remember that the 3 represents wins, the 5 represents losses. I remember that. Okay, now here's the thing. And they play 80 games. You hear that? And they play 80 games. How many wins should they have? So here's the thing. When students start hearing this question, they're like, wait a minute, I don't know if I truly understand what's happening. I'd say, well, look, you have a ratio, right? And this is 3-5. Now, what does the 3 represent? You'd say wins. And I'd say, what does the 5 represent? Losses. I'm going to say, okay, good. But here's the thing. In order to have 3 wins and 5 losses, how many games did they have to play in order for that to happen? You'd say, well, that's 8 games, right? I'd say, yeah, exactly, because that's part wins, right? To part losses. And if I put those together, that means that they played a total of 8 games. So that means my total would have to be 8 games. So if they played 8 games, then 3 of the games were wins, 5 of the games were losses. Students will say, well, how did you get to 8? I'll say, well, I added 3 plus 5. 3 wins plus 5 losses equals playing 8 games. This is the reason you should start using more language instead of just saying 3 plus 5, because then that doesn't make any sense. You're like, why did you add 3 to 5? I'm like, exactly. Why did you? Because it's wins plus losses equals total games. And that's a better way to talk about math. Okay, instead of just saying arbitrary single numbers, which are meaningless, start using the language. Wins plus losses equals total games. And I guarantee you, your math is going to completely change. Okay, so here we go. Let's start with that information here. So I tell you, hey, the team played 8 games, and this is how their ratio broke out. Now, this is their ratio, which means it's never going to change. It's never going to change. You're not going to all of a sudden they're going to have a winning season. It doesn't talk like that. It doesn't say like they lose most of the time. That's basically what you're saying. You're saying for every 8 games they play, they're going to lose 5 and they're going to win 3. And it's not going to change. So if they play another 8 games plus another 8 games, guess what? It's not going to change. Sometimes students start to say things like, well, maybe they got better. No, 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 no. The whole thing is that this is math. We are not talking about a real team here where this is math. And math is using this ratio and saying for every 8 games, they win 3, they lose 5. And guess what? When they play the next 8 games, the same thing is going to happen. And guess what? When they play another 8 games, the same thing is going to happen. So we're not talking about real people where they're creating some strategy. What we're saying is we're saying this is math. And we're saying for every 8, 3 wins, 5 losses. Another 8, 3 wins, 5 losses. Another 8, 3 wins, 5 losses. Now, here's the thing. These games keep adding up. 8 plus 8, now we're up to 16. Plus another 8, now we're up to 24. They want to tell you, well, what happens when they get to 80? When they get to 80, how many wins have they accrued? How many losses have they accrued? Did you hear that? Did you hear that? So another way to think about that is this, because I kind of like, that's where I like to leave students usually when I'm talking to them about this. I like to leave them right there and say, now you sit down and think about it. Think about it for another minute or 2 minutes. Think about what I just told you. For every 8 they play, this is gonna happen. Then they play another 8. The same thing's gonna happen. Another 8. How many? They're gonna get to 80. So how did the wins break out? How did the losses, right? It's gonna be definitely way more than 3 now, right? It's gonna be definitely more than 5. How many? So I'll leave it with the students like that for a minute. So you can go ahead and pause the video and kind of come up with something and see what you think. But I'm going to bust out another way to think about this. So another way to think about this is to use the fractions that we kind of came up with. Remember the equivalent fractions that we came up with before? You can kind of use the same again. Now, there's a thing called proportional equation. I show it in the next video. It is exactly what I'm about to show you, but I like to say the word equivalent fractions because that's exactly what's happening here. So let's build a fraction, and I'm going to build it based on what they told me and then what they're asking me. So again, remember they told me 3 wins, 5 losses, and they say what happens when they play 80 games. So here's the thing. I'm going to use some of the information that's already here. So remember we said 3 wins, 5 losses. I said, oh, that equals 8 total games. Remember we talked about that? Okay, I'm going to use this information and I'm going to calculate wins. Let me show you what I mean. So if I said, hey, what's the ratio of wins that the team had? So I'd say, well, based on 3 to 5, its wins is 3 out of 8. Students will say, well, hey, wait a minute, where did you get all that? 8 is wins, 8 is total. All right, we talked about that, right? 3 plus 3 plus wins plus 5 losses equals 8 total games that they played. So for every 8 total games, they win 3, right? Okay, that's how this ratio got built. Okay, now what I'm going to say is let's make an equivalent fraction, which means I'm going to make another fraction over here, and we're going to make another equivalent one. And instead, and for my total, I'm going to turn it into 80. Right? Because that's what they're asking me there. It's saying what if they play a total of 80 games, then how many wins should they have? Well, I'm going to use this information here to solve by making equivalent fraction. And it says this, hey, in order to get from 8 to 80, what do I have to do with this fraction? How does 8 become 80? You'd say, well, you multiplied it by 10. I'd say exactly. So I'm going to multiply the 8 times 10 to get to 80. So that means I have to, in order to make an equivalent fraction, you do the same up here to the numerator, which means it's going to be 3 times 10, which makes 30. Now, let's use that information. Remember, 30 wins. How many losses? 50. And if you're like, wait a minute, how did you get to 50? I'm saying, well, look, remember, it's 30 wins. They played a total of 80 games. So they didn't win everything. How many did they lose? You'd say, oh, well, that's 80 minus 30 leaves 50. I'd say exactly. So it's 30 wins, 50 losses. That's a total of 80 games. So this is another way to talk about things. Now, this is where students really need a little more help. So I'm gonna tell you to take your time with this, do plenty of homework, okay? Um, do a lot of examples. Watch the next video, which is the proportion equation, because it shows you how to set up these equivalent fractions, and maybe it'll make it a little easier to solve these proportion questions. Okay, so good luck with everything. I'll see you in the next video.